Good morning, students. Myself, Divya Jain from Technocrats Institute of Technology, Bhopal. Our today's topic is Z transform and its properties. So for that, what is Z transform? What is Z transform? That is used to convert time domain signal xn, to frequency domain signal xz. Some other type of transform are also there. The formula for finding out the Z transform of time domain signal xn is summation n is equals to minus infinity to infinity xn z to the power minus n. Some other kind of transforms are Fourier transform, Laplace transform, These kind of transforms are used to convert continuous time signal into frequency domain. And the Z transform is used to convert digital signal from time domain to frequency domain. It is used to convert digital signal from time domain to frequency domain. Now the relation between Laplace transform and Z transform. Laplace and Z transform, the relation between Laplace transform and Z transform. Laplace transform is represented as xs is equals to minus infinity to infinity xt e to the power minus st dt, where s is sigma plus j omega. And Z transform is represented as xz is equals to, for digital signal, the integration is converted to summation and t is replaced with n for digital signal. So xt is written as xn e to the power minus sigma plus j omega n. Now, it can be written as xn e to the power sigma into e to the power j omega raised to the power minus n. Now we can take e to the power sigma is equals to r. So xz is equals to summation n is equals to minus infinity to infinity xn r e to the power j omega raised to the power minus n. Here we can take r e to the power j omega as z. So the final formula for finding out the Z transform is xz n is equals to minus infinity to infinity xn z to the power minus n. This is the final formula for finding out the Z transform of any input signal xn. Suppose we are having a sequence xn is equals to 1, 2, 3, 1, 6. This is our input sequence. So for finding out this the Z transform of this sequence, xz is equals to summation n is equals to minus infinity to infinity xn z to the power minus n. So here we are having sequence from minus 2 to plus 2. So this the Z transform of this sequence will be 1 into z to the power plus 2 plus 2 into z to the power 1 plus 3 into z to the power 0 plus 1 into z to the power minus 1 plus 6 into z to the power minus 2. This is the Z transform of this given sequence, and because we are having positive as well as negative power of Z, so this Z transform is double-sided sequence Z transform, double-sided Z transform, double-sided Z transform. Now I am going to discuss the properties of Z transform. Properties of Z transform. First property is linearity. Second is time shifting. Second property is time shifting. Third is time reversal scaling. Fourth is time reversal. Time reversal. Then differentiation. Differentiation property. And then convolution. Then convolution. So first we discuss the linearity property of Z transform. Linearity. The statement for linearity property says that A1 x1n plus A2 x2n. Transform of this sequence is what? A1 x1z plus A2 x2z. Means A1 x1n, A2 x2n, both are combined. After that, they are passing to the system and take the Z transform. We will have Z transform of A1 x1n, A1 x1n plus A2 x2n. Clear? And if we take the Z transform of both the sequence separately and after that combine the sequences x1n, x2n, A2 x2n, take the Z transform of the sequences Z1, Z transform of A1 x1n and Z transform of A2 x2n. And then we combine both of them. If this is equal, then it satisfies the property of linearity. This will satisfy the property of linearity. So if we prove this property, the proof of this property is what? Z transform of A1 x1n plus A2 x2n means n is equals to minus infinity to infinity A1 x1n plus A2 x2n z to the power minus n. After expanding this, we will get n is equals to minus infinity to infinity A1 x1n z to the power minus n plus n is equals to minus infinity to infinity A2 x2n z to the power minus n. So we will get A1 x1z plus A2 x2z. So This is the property of linearity. Now the next property is time shifting property. Time shifting property. The statement of time shifting property is that if Z transform of Xn is Xz, then Z transform of Xn minus K is Z to the power minus K Xz. So proof of this property is Z transform of X n minus K is equals to n is equals to minus infinity to infinity X n minus K Z to the power minus n. Z to the power minus n. Now replace this n minus K with m. So this will become m is equals to minus infinity to infinity xm Z to the power minus m plus K. Means the transform of X n minus K is equals to summation m is equals to minus infinity to infinity xm Z to the power minus m plus K. So if we take Z to the power minus K outside the summation, so we will get summation m is equals to minus infinity to infinity xm Z to the power minus m. This is equals to what? Xz. So this is the proof of our time shifting property. Means the Z transform of X n minus K is what? Z to the power minus K, Z to the power minus K xz. Now the next property is scaling property. Now the next property is scaling property. If Z transform of Xn is Xz, then Z transform of a to the power n Xn is Xz by a. So the proof of this property is the Z transform of a to the power n Xn is what? N is equals to minus infinity to infinity a to the power n Xn Z to the power minus n. Z to the power minus n. So we can write it as n is equals to minus infinity to infinity xn a inverse z raised to the power minus n. If z transform of, if this equation n is equals to minus infinity to summation n is equals to minus infinity to infinity xn z to the power minus n can be written as xz, then n is equals to minus infinity, just a minute, n is equals to minus infinity to infinity xn a inverse z raised to the power minus n can be written as x z by a. So we have proved that property, that a to the power n xn z transform of a to the power n xn is what? X z by a. So this is our scaling property. Means if we multiply a to the power n with our input signal, we will get xz by a in the frequency domain. Now the next property is time reversal property. Time reversal property. It says if the Z transform of xn is what? Xz, then Z transform of x minus n is what? X Z inverse. So proof of this property is the Z transform of x minus n is n is equals to minus infinity to infinity x minus n z to the power minus n. So replace minus n with m. So it will become m is equals to minus infinity to infinity x m z to the power m. So here we can write it again. X of minus n is what? M is equals to minus infinity to infinity x m z to the power m. We can write it like this also. M is equals to minus m infinity to infinity x m z inverse raised to the power minus m. So if m is equals to minus infinity to infinity xm z to the power minus m can be written as xz. So m is equals to minus infinity to infinity xm z raised to the power minus 1 minus m can be written as xz inverse. So we have proved our statement that Z transform of x of minus n is what? X Z inverse. This is our time reversal property. Now the next property is differentiation property. Next property is differentiation property. Differentiation property. This property says that if the Z transform of xn is what? Xz. Now the transform of n xn is minus z dxz by dz. This is the statement of our differentiation property. So for proving this property, first we take that xz is what? N is equals to minus infinity to infinity. N is equals to minus infinity to infinity xn z to the power minus n. So first we take the differentiation of left hand side dxz by dz. So we take the differentiation of right hand side also, d by dz of summation n is equals to minus infinity to infinity xn z to the power minus n. Z to the power minus n. Just a minute. Z to the power minus n. Now take the differentiation of right hand side. So d xz by dz is equals to d by dz of summation n is equals to minus infinity to infinity xn z to the power minus n. So take xn as a constant from the summation side. Take out is Then n is equals to minus infinity to infinity dy dz of z to the power minus n. Z to the power minus n. Just a minute, students. Z to the power minus n. So if we take the differentiation, we will get xn minus n z to the power minus n minus 1. Summation n is equals to minus infinity to infinity. So we can write it as minus n z to the power minus 1 summation n is equals to minus infinity to infinity xn z to the power minus n. Here we have done the shuffling of terms, nothing else. So now we can shift this z inverse into the left hand side. So we will get z dxz by dz, dxz by dz is equals to minus sign is also take left side. So we will get n, just a minute. Summation n is equals to minus infinity to infinity n xn z to the power minus n. So this is nothing, it is the z transform of input signal n xn. So we can write it as minus z dxz by dz is equals to z transform of n xn. So this is the proof of our statement that n xn, the transform of this input is what? Minus z dxz by dz. This is called differentiation property of z transform. This was our statement and we have proved that. Now the next property is time convolution property. Next property is time convolution property. Time convolution property. This property says that if we take the convolution of two sequences in the time domain and take the Z transform of these convoluted sequence, we will get the multiplication of both the sequence in frequency domain. So proof of this property is Z transform of x1n convolution with x2n. So according to the Z transform formula, first we just a minute. First we take the formula for convolution. The formula for convolution is x1n convoluted with x2n is equals to summation k is equals to minus infinity to infinity x1k x2 n minus k, x2 n minus k. So the Z transform of x1n in convolution with x2n is summation n is equals to minus infinity to infinity. Our input signal is what? convoluted signal. So this is our convoluted signal, which we will take as input for taking the Z transform. X1k, X2, n minus k, Z to the power minus n. So first we just rearrange the equation. So take k is equals to minus infinity to infinity summation of, and take x1k outside and take the summation n is equals to minus infinity to infinity x2 n minus k z to the power minus n. Okay, now according to time shifting property, what time shifting property says? Time shifting property says that the Z transform of x minus k is what? Z to the power minus k xz. So this term can be replaced with, so the Z transform of x1n in convolution with x2n is what? Summation k is equals to minus infinity to infinity, k is equals to minus infinity to infinity x1k, and the second term that is n is equals to minus infinity to infinity x2n minus k z to the power minus n can be written as z to the power minus k x1z. Take x1z out and we will left with only summation k is equals to minus infinity to infinity x1k z to the power minus k. And this is the Z transform of just a minute. It is x2z. So we have x2z outside the summation, and this will become x1z. So this is the proof of our property, convolution property. It says that in time domain, if we take the convolution of two sequence, after performing the Z transform of these time domain convoluted sequence, we will get the multiplication of frequency domain of both the sequences. So this is all about the properties of Z transform. Thank you, students. Thank you very much for listening patiently.